Okay, so we're going to be talking about 1.4, both Desmos and Ready, Set, Go. And then we're going to talk about slide 14, which is retrieval problem number 1. We did problem number 2 during class, so go and watch that video if you need to. Here's all the work for it. And then, so what we want to talk about is this: write an equivalent expression for 7 to the negative 9th times 7 to the 4th, and then leave your answer in exponential form with only positive exponents. Okay, so if they're asking me to do this, I'm reaching back into my memory of what happens with this. So people ask all the time, Ms. Johnson, what's the rule for this? And if you don't remember the rule, it's useless for me to tell you the rule. I'll just show you what they mean. So I'm going to bring you back to the definition of them. So the definition of, I'll start with 7 to the 4th. 7 to the 4th literally just means, let's write this down. 7 to the 4th literally means just 7 times 7 times 7 times 7, right? That's what 7 to the 4th means, right? So this part here is this part here. Now, if we're talking about 7 to the negative 9th, I need to remind you of a definition, okay? So people think all the time that, my students get this wrong, the negative exponent means it's a negative answer, and that's not true. And so let me just show you a little like helper to remind you, okay? If I look at 7 squared, that's 7 times 7, and then that equals to 49. I'm really not interested in the 49 business, but just kind of go with me. If it's 7 to the 3rd, really that's just 7 times 7 times 7, which is whatever number that is. I kind of don't, that's not our concern right now, right? So if you notice, when I'm going up this way, all I'm doing is multiplying by 7. That's the pattern, right? From 2 to 3, I just multiplied by 7, right? So in math, I want you to think about, okay, well, how would I get down to the negatives? Well, I'd go this way, right? And this would be 7 to the 1st, which if you think about it, that's just 1 7, right? It's just 1 power of 7. Now, here's the interesting part. If you notice, this is not being multiplied by 7. If I go down this way, it's actually being divided by 7, which is a good thing for us to remember, because that's how we get one of the proofs for 7 to the 0, and then also for our negative exponents here. So I'm going to keep going down. So this is going to be 7 to the 0, which means there are 0 7s here. There's 0 factors of 7 here. So Ms. Johnson, what would that be? Well, if you think about this one, this is really 7 divided by 7, because we're just dividing by 7 every single time, right? So here, we're just going to divide this by 7. And what's 7 divided by 7? Oh, that's 1, right? And that's why 7 to the 0 is 1. Okay. So if we keep going, right? If we keep going, now we're in negative land. Let me use my fancy, like, I don't know, I call this my like rainbow pen. It's 7 to the negative 1st, right? Because if you look at the pattern here, the pattern goes 3, 2, 1, 0, -1, right? And so if you notice, we're still just dividing by 7. So, okay, fine. What is, this is the question for this one, what is 1 divided by 7? Well, that's what it is. It's 1 divided by 7. So here's the most powerful thing I want you to see, but wait, let's let that marinate for just a second here. Okay. So then what would 7 to the negative 2nd be, right? What would that be now? Let me choose a different color here. What would 7 to the negative 2nd be? Well, then that's just, again, dividing by 7 again. So that would be 1 over 7 times 7. Right? So if you notice here, the factors of 7, 3 of them are on top of the fraction, versus down here, this negative says it's on the bottom of the fraction. And we talked about this a little bit ago. Remember when we did, I think it was the ready problems, and they had the negative exponents? This is why, right? Because all you're doing is you're dividing by factors of 7 if your number is going down, right? Negative numbers, right? Or you're just multiplying by 7 as the numbers go up, right? So here, what's powerful is your negative exponents are not negative answers. They're just like factors of dividing by 7, which makes sense because exponents is factors of multiplying by 7. Does that make sense? So here, 7 to the negative 9th, going back to our problem, wouldn't be 7s on the top. They'd actually be 7s on the bottom. So 1, 2, 3, 4, 5, 6, 7, 8. I'm going to put this guy up front. 9. Now, Ms. Johnson, couldn't you just tell us the answer? Absolutely. But I can't tell you the answer during the quiz. So I want you to go back to your definition. So if you notice here, what would happen, and some of you are like, oh, Ms. Johnson, they divide out and they cancel, you'd say. And I'd say, yeah, they cancel because they divide by 1, right? So 7 divided by 7, here, let's use my fancy colored pen. 7 divided by 7 is 1. 7 divided by 7 is 1. 7 times 7 divided by 7 times 7 is 1, right? So in reality, what do we have left? We have 1 over 7 to the 5th. 1 over 7 to the 5th. And so my good mathematicians are saying like, hey, how could you go from here to here without all this business right here, right? And absolutely, you can actually do that. So when you get really proficient at exponents, you should be able to go from here to here without all this. And this is going on in your head, right? So in reality, you should be able to see, oh, negative 9 plus 4. So negative 9 plus 4 is negative 5, right? And 7 to the negative 5 means 1 over 7 to the 5th. Sorry, let my ink catch up to you. I like to say that I am faster than my computer. Not really, it's just I'm faster than my Wi-Fi right now, right? Okay, so in a second, you'll see this come through and then that should make more sense, right? Let me check my chat really quick. Very good. All right, so you would take your exponents because they have the same bases. Negative 9 plus 4, yes, is negative 5. And then 7 to the negative 5 just means we have 7 factors of 5 on the bottom. So there's your answer. Let's just check my answer. Write an equivalent expression, correct. Leave your answer in exponential form. That's an exponential form with only positive exponents. See how this is a wrong answer because the exponent is negative. So you know how I'm a fan of checking your answer. So answer checking would look something like this, right? You go back to Desmos, my friend, right? And we check our answer by looking at this or this right here versus this right here. So I'd write 7 to the negative 9th times 7 to the 4th. I don't really care what this number is. I just care that when I simplify this one, it's the same. So 1 divided by 7 to the 5th, I hope gives me the same exact. It does. Yay me, right? Okay, so that's that. Do that one. And then also 1, 3, 6, 8. Okay, so let me just check 1, 3, 6, and 8. Ready to go. 1, 3, 6, and 8. Okay, I will do these together on the same video just so that we have some. Yay, I'm so glad. Okay, so I'm going to do 1, 3, 6, and 8 now. Actually, I'll probably do 1 and 3 and then make you do 6 and 8 just to check. So if you go back to the definition of, and I don't know if you guys recognize this, but I'm a huge fan of go back to the definition, forget all those like rules that, you know, you may have forgotten, because if you go back to the definition's never going to serve you wrong. So 3 to the 6th literally means 3 times 3 times 3 times 3, times 3 times 3. And then this is 3 to the 6th. And then 3 to the 5th looks like this. Okay, fine. What's the answer then? 3 to the 6th times 3 to the 5th is 3 to the, oh my gosh, there's a lot of them. And then you would count it. Right, hold on, let my ink catch up to me. Doesn't like to catch up to me. I'm just gonna wait till my ink catches up. Okay, here it goes. So then we have this many threes here and this many threes here. The answer is gonna be 3 to the something. You can just count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And you're like, oh, Miss Johnson, the answer is 3 to the 11th. Oh, that makes so much sense because 6 of them and 5 of them makes 3 to the 11th, right? So keep that in mind. I'm actually not going to do this one because now you understand how to do this. So try that one and then we'll check this one.